Okay, hello, good afternoon and good evening to one and all.
Good afternoon, ma'am.
Yeah, myself, Deepika Jain, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, I welcome you to the just a minute, is someone coming? 8th International Conference on ICT for Sustainable Development, that is ICT4SD 2023, Goa, India. The 8th edition of this conference is being held via physical mode and digital mode as well. And the physical event was being held at Goa on 3rd August. And the virtual event is being held through Zoom platform. I hope you will enjoy the knowledgeable session throughout the day. In this session, we have 10 presentations and each presenter would be getting 8 minutes for their presentation and 2 minutes for any question and answers if there are any. Yeah, I will be giving you time checks in between, and I request all the participants to stay with us till the end of the session. And if you have any query, you can just drop me a message through the chat box. And just a minute. There is. We have a session chair with us, that is Professor Priyanka Verma. She is an experienced educator and trainer in the area of lecturing and technology with a track record of working in the higher education industry. Skilled in computer networking, Microsoft Excel, communication skills, leadership skills, creative thinking, teamwork, critical analysis, and problem solving. She's also a strong consulting professional, graduated from Institute of Engineering, Kolkata, and National School, the IIS University. Currently working as an associate professor since 2015 to till date. She also does part-time research on data science. I welcome you to the session, ma'am.
Thank you, Deepika.
Yeah, okay. So we can start with our first presentation. Do we have Kumar Keshamoni with us? Okay.
Recording in progress.
Okay, so we have the next presenter, Dattare. Dattare is here.
Yes, ma'am. Yes, I am present.
You are present, right? So you are going to present your paper on analysis of clinical decision system in healthcare industry using machine learning approach, right?
Yes, ma'am. Right.
Yeah, you can start sharing your screen.
Yes, ma'am.
Share your screen, please.
It is visible, ma'am?
Yeah, it's visible. You're audible as well. You can start.
Yeah, okay. So, good afternoon, all of you. So, today I am going to present my research topic, analysis of clinical decision support system in healthcare industry using machine learning approach. So, today, currently, it is very big issue related to the medical health. So now I am trying to solve this issue by using one machine learning algorithm like a clinical decision support system. So this is the content of our my research: introduction, motivation, objective literature survey, system architecture, result, conclusion, and references. And this is the introduction. In that, basically, the clinical decision support system are the electronic instrument create to help healthcare professionals to defensible choice about the patient treatment. So by using some machine learning algorithm, where solve this issue, we have used here two machine learning algorithm. One is the hierarchical temporal memory, and second is short-term temporal memory. So basically, STM is used for the collecting the data from the sensor node and predict the map. Map means it's a mean arterial pressure. So STM basically used for the find out the exact value of map, and LSTM is basically used for the classification. Means patient is uh, required a treatment or not. So normally, if the value of map is greater than 100, so we are trying to give a treatment to that patient. So this is the basically introduction. In that, there are basically we are trying to solve this medical issue by using STM and LSTM algorithm. Now these are the motivation. So in that motivation, we are motivated behind the analysis of clinical decision system in the healthcare industry by using machine learning approach stems for the pressing need to enhance healthcare decisions making and improve the patient's outcome. Means by using our system where increase the patient's improve the patient's outcome by using large data set. Now we are collecting the data from the some sensors node. Those are available in every hospital. We are collecting some blood pressure related, sugar related. Then this all the data set we are collecting from the some sensors node. Those sensors node are already available or already attached to some medical instrument, and we are collect some these types of database, and these types of database, based on that database we are calculate the map value, and this map value we are give to the LSTM algorithm for the classification purpose. So this research is motivated by the belief that integrating machine learning technique into CDSS can significantly enhance the capability, resulting in better diagnosis, treatment planning, and overall patient care. So basically, we are creating one system for the overall patient care. And last is clinical decision support system is a more precise and timely diagnosis, reduce a medical errors by using the any digital system where removing the some errors related to the medical reports, improve the treatment outcomes, and better resource utilization in healthcare facilities. These are the motivation. And next is objective of my research is the proposed real-time clinical decision system has two main goals. First is we offer decision assistance for use of medical professional in the clinical setting and to provide real-time prediction of mean artery pressures value. Means we are trying to find out the map value by using the STM algorithm. So a second objective is the purpose of this system is to analyze vital science streams in real time. So we are collecting the data at real time by using the STM algorithm, and STM algorithm, the process victim science teams are then subject to several methods of feature extraction and selection in order to identify the characteristic that's most important for accurately predicting the map. So if map value is greater than 100, so it is we are trying to give the treatment to that patient. So our goal is finding the map value. So and next objective is a prediction model, and we are by using the STM model we are predict, and by using the LSTM classifier, it is used to make guess that what map value will be based on the characteristics that were choose. The anticipated value of map is provided on the user interface, which offers decision help medical professional working in clinical setting. And last objective is the purpose of the system has been developed to make it is possible to identify change in map values earlier than was previously possible. and to provide timely decision assistance to medical professionals working in intensive means ICU department. It is possible for that system to assist a medical practitioners in the medical educated choice and enhance the patient's outcome view provision of precise and dependable forecast. So these are the objective of my research. And next is problem definitions. So problem statement is what the system aim is to predict mean RTL pressure value in real time and provide a decision support to healthcare profession. This is my problem definition. And ICU and doctors may be benefits in the form of by using these two algorithm, LSTM and STM model, for getting good accuracy, good precision, good recall, and F1 score. So these are the accuracy, precision, and recall. Recall and F1 score is the parameter of for calculating the performance of our system. So next part is literature survey. So we have studied some research paper, more than 10 research paper we have studied. Those research papers are related to the machine learning algorithm. So in first research paper, we have used hierarchical temporary memory and long-term short-term memory algorithm. Second literature paper or research paper, I have studied the backpropagation neural network. Third research paper, we have studied support vector regression. So there are different machine learning already available in So we have studied this research paper, and based on that, we have decided which one algorithm is better for getting the good accuracy. So now next part is system architecture. So this is the overall system architecture of our system. So in that we are collecting the input from various sensors node or various medical instrument, and this input we are giving to the one algorithm having name is STM, and STM is basically used for the predicting the map value of that patient. Okay, and LSTM algorithm is basically used for the classify what type of classification. That means the patient's patient required a treatment or not. This type of classification is done by using the LSTM algorithm. So now this is the data set of those we have provide to my research algorithm. So basically based on this parameter like blood pressure, heart rate, arterial complement, and total peripheral residence. Based on this parameter, we are calculate the map value of every patient. So I have already discussed if map value is greater than 100. So that patient is required to give some treatment. So we are calculating this map value by using the STM algorithm. Now this is the result by using the we are combining the two algorithm, LSTM and STM algorithm. So based on this algorithm, we
Dear
got
presenter, please conclude. You have already exceeded the time.
yes. Yeah, by using the combinations of LSTM and STM algorithm, we got good accuracy, good precision value, good recall value, weapon score, as compared to those algorithms are already available. So this is my conclusion, and this is the references. Okay, thank you.
Thank you for your presentation. Any questions, ma'am?
Deepika, you may move on to the next presentation.
Any questions, ma'am?
No, Deepika, you may move on to the
Alright,
next presentation.
Yeah, all right.
Okay, ma'am.
Thank
Thank
you
you.
for your
Thank you.
presentation. Thank you.
Can you share me the poster? Please.
Yeah, I'll share you that
Okay, ma'am.
in the
Thank you.
chat. Yeah.
Thank you.
Okay, so our next presenter is Darshan, who would be presenting a paper on backend generator. Are you here, Darshan?
Yeah, I'm here.
So you can start. Yeah, you can start sharing a screen.
Yeah, is the presentation visible?
Yeah, it's visible.
Yeah, good. So I will present you backend generator. It is a backend API route generator. It generates codes from OpenAPI spec for Golang, language developed by Google. So yeah, so about me, so about authors. So I'm Darshan Nandat, Ranav Dani, Dhairya Panjwani, and Dr. Darshan Inge, our professor. We all four worked on this paper to publish it. And yeah. So why we wanted to build something like this? So personally talking about myself, I am a backend and app developer. So I work with these things a lot. So I found it very difficult and annoying to write the same code again and again. So yeah, so talking more about that, how backend thing, where it affects and whatnot. So it basically, some stats, it basically gives you 48% of development code, like it saves that much time. So it generates 48% of code. We tested this on a simple to-do application. So the request would come, the to-dos would be saved, and serving the to-dos and the 4 CRUD requests. So that's there. It is less error prone because the code is generated and it is like less prone to errors as it is tested and it already runs. So yeah. So what during the literature survey, we found that there is no single project that does this end to end. So providing you a simple drop-down menu solution to create open API specs to generating the code. Whereas we couldn't find any of that solution. These were the examples that we found. The solutions that we found were Swagger codes, and basically this only generates the code. You have to provide the open API spec, and you can kind of write open API spec in Postman and Hopscotch, but they are very limiting in code generation. So we kind of tried to combine these two things together to build the project. So this is the architecture of the project. So we have divided this thing into 2 modules. One is the web module, the thing that the user would interact with, and the final is the generator. The reason for separating these modules were to have a better kind of like, if someone wants to just use the generator, not the web interface, or if it wants to run on a CI environment, so they won't have a dependency on web module. So they can directly use the generator without having the web module, and web module basically adds an extra ease of use to the generation process. So first of all, the user would use the front end and to define the open API specs and like basically uses buttons and defines routes, models, the structure of the API and the response in the front end, and then it sends it to the backend, and backend in turn runs the generator to build the code and to serve the file back to the front end. So user can directly use that. And what the generator does is basically it takes the API routes and the models from the request, and it generates the code for them. So this is the general backend application, how it looks like. So the user might get the backend might get a request, and we have to handle the request and perform some actions to it, and then send a structured response to the requestee, the requester. So basically what we have generated is to handle the request and to send the response. So the structure of both this request and response models and the handling part of these things are generated by us and generated by Backgen, and finally the get like handling the response, and if you want to store it to a database, if you want to manipulate the data, or if you want to cache it, that is done by the developer itself. So it is a developer assistant tool, not a developer replacement tool. So that's there. And finally, what do we generate is basically route handlers to handle get request, post request, options, and all other kinds of requests. Currently, it doesn't support WebSockets, but yeah. Finally, it generates routes and responses, and it also handles JSON parsing, parsing JSON to object and object to JSON. So is that, and thank you. Here are my credentials for social medias and my site. Any questions?
Darshan, I have a question. You said
Yeah.
that it's a replacement or somewhat more useful than Postman, right?
No, it is not a replacement for anything. It is
Hmm.
basically an assisting tool, so you can start your project quickly. So instead of
What exactly is it helping in? Because Postman is something which helps to connect your Python with the Android-based platform, right?
no, ma'am. So Postman basically it is a kind of testing suite to test all the requests are working properly or not. So
Hmm.
it kind of gives you the open API spec and helps you generate some code of it, but won't help you to generate the backend part of it.
Because
So
recently my students worked on a project, so what they made use of this Postman and Heroku, right? So
yeah.
what I'm trying to ask over here is that if you have developed this platform or something, API which is just helping out, so what exactly is the purpose? I mean, where all we can implement it?
Okay, so ma'am, if you want to generate if you want to make a backend, so you write API routes and where the request would hit and what kind of structure the data would be in. So this would generate that code base to handle all the routes and the parsing of the structure. So let's say if we send a JSON response of request of name and ID, email ID. So it will create an object for us that would parse it and give it to us, and then we can take it forward to manipulate it or to save it in the database or whatnot.
And in what kind of application can it be implemented? As in web-based, mobile-based, what kind of application?
So this is a server environment thing. So it is not specific to any kind of mobile or web or desktop.
Okay, thank you, Darshan.
Yeah. Thank you. Any other questions? Thank you.
Right, so we have our next presenter, Aditya Joshi.
Yeah.
Yeah, you would be presenting on reduction of quality and shelf life of fruits and vegetables using neural networks. Okay, so you can start sharing your screen.
Sure. Let me share my screen. So let me know when it is visible.
Yeah, it's visible. It's visible.
Awesome. So as you can see, my first of all, good afternoon, everyone. Thank you for this opportunity to present in this conference. So my paper ID is 443. The title of paper and my problem statement, you can say that we are detecting the quality and shelf life of fruits and vegetables, and we are using neural networks to do that. So like abstract about the whole research thing is that we are using first is machine learning models, specifically CNN. So we are classifying the images, whether they are fruits or vegetables. We have a data set of images to, like we have used the data set to train the model as we do with all the models. And then using those models, we determine the quality and the shelf life. So quality is basically the fruit is good or bad. And shelf life is basically how many days would the produce or the fruit or vegetable would survive. So like there's plenty of things to do here, but like for now I've just considered two cases. So like, for fruit we have considered tomato, and for vegetable we have considered potato. Now coming to literature survey, when our group did this research, we found around 16 related topics that were specifically providing these solutions, and there were two prominent approaches that were used in almost everyone. So first approach was they take an image, they convert it into HSV scale, they negate that image. So basically what happens when you negate is it turns into black and white, and then the damaged spots on the fruit or the vegetable skin is visible. So basically every picture is turned in a black color, and the damaged spots are visible as white colors. And that is used to classify the fruit if it is ripened or if it is a diseased one. So this was first approach. Second approach was they use the RGB scale. And so this is for tomatoes specifically. If you say, then the range of tomatoes, let's say 200 to 255 is the color range for red tomato, right? So basically what it does is that they take the image, they identify the RGB scale, and they mark the darker spots, right? So if a tomato is basically in the darker, like if there are darker spots on the tomato, it is damaged, right? So like these are like two prominent approaches. There are other approaches, but like that weren't much prominent, and like these two were most prominent in most of the research articles. Now the system we are proposing here is basically using the CNN. So this is a simple architecture of the system that, you know, first, whether it is a data set of images or if it is just a test image, we get it into our system, then we do data processing. So data processing would have all these steps like resizing the data, you know, making it into the color gradient and everything, and then it is converted. And then if you can see the model creation, model training, and model evaluation. So this is basically done to prepare that model. Once that model is prepared, then we are ready to predict the result, and then we get the predicted result. Now the process that we did to get everything together, the first thing was to create a data set. So what we did was we went out there, we clicked pictures of tomatoes and potatoes. So let's say there are like green tomatoes, yellow tomatoes, red tomatoes, some damaged tomatoes, pure red tomatoes, in sunlight, in darkness, like every angle. We tried to capture every angle and, you know, every possibility of it. Roughly we had around 3,000 images, which is still low, but like as it is a naive approach to as it is a naive approach to, you know, like present the thesis, we considered it as a good number to go ahead with. So roughly we had 3,000 images, and then we just created labels. So let's say the tomato, so good tomato, bad tomato, then there are diseases in tomato, let's say anthracnose or wilt or like any other disease. So we had classes of that, and then we just added the images of those particular classes to the respective labels. So this is like the breakdown of what the classes looks like and the number of images in it. So if you see in the quality detection, so there are two basically like different data sets. As I said, we are detecting the quality and shelf life. So for the quality, we have good tomato, bad tomato, wilt, fruit cracking, and anthracnose are basically the diseases in tomato. And then for potato, we have good and bad again. And if you consider shelf life, so shelf life, we have 4 categories for tomato. It is 0 days. That means it is completely damaged and you should just throw it away. Then there's 1 to 5 days, 5 to 10 days, and 10 to 15 days. Same for the potato. So potato, like the throw it away means the potato is damaged and you should throw it away. Store it in dry place is basically, it is a good potato. Now the second step when we created a data set was to build the model actually, right? So what we did was we took the data set, resized all the images, because, you know, when we click pictures from mobile, the orientation is not well suited and it is not uniform throughout all the images in the data set, right? So for that, we resized the images. Then we did some data augmentation to scale the images. So data augmentation basically works as in it just tilts your image, let's say in right direction or left direction. So basically, this is a small data set and we just have to make it big. So it just do some combination and basically creates new images, and it is helped in scaling the data set. Then we create a CNN model and then of course train it. And like once it is trained, we, like the normal process, we evaluate the model prediction and find out the accuracy and then predict on the test data set. Right. So these are actually, we tried a lot of different things, but like these are the ones that did well. And if you see the last one, the last model, CNN VGG16, it had 20 epochs, 16 layers, 80-20 split, Adam optimizer, and we were able to achieve the accuracy of 80%. Now the accuracy is still low, but as I said earlier that, you know, this was like a naive approach to the to this thesis. So it can be improved again. So the VGG16 here is basically a CNN model that is pre-trained on some images. So it is basically specifically used to do the image classification thing. So there was a competition called ImageNet, and the VGG16 model was the winner of that competition. And it basically is able to classify 1,000 images in 1,000 different classes with around 90 to 95% accuracy. So we just first we tried with the normal CNN models, but the accuracy wasn't much satisfying. So what we did was we took the VGG model and we fine-tuned it on our dataset to basically get the results that are suitable for our dataset. And now the highest accuracy we have achieved is close to 80%, and we again try to improve that in the future. So the results, as you can see, on the left side are quality detection. On the left side, on the right side, it is shelf life detection. So as you can see, there are tomato bad, potato bad, or if you see the shelf life, there's 0 days, 5 to 10 days. So the basically the results are, as I said, that 80% is there. So if you provide the model 100 images, it would get out roughly 80 of them correct. So these were the results of our data set of our model. Now coming on to the applications. So the first is food industry. So actually the idea was from here that many restaurants or food chains, they provide French fries or ketchup. So they have the conveyor belt where the fruits or vegetables are just moving, and person manually picks the damaged ones and throws it away. So that's a repetitive task, and it can be automated. So by using this model, we can just set up a camera and maybe identify which one are good, which one are bad, and then have a robotic integration that would basically filter out the bad ones and just process the good ones. So that could be used in food
Dear
industry.
presenter, just conclude faster, please.
Yeah, sure. I just have 2 slides left, so I'll be done. Then we have retail industry. So retail basically, if you go to any food shopping mall, or maybe where vegetables and foods are sold in wholesale or retail, you can see that there are problems of storage and inventory. One day there are thousands of fruits, and the other day all of them are wasted because there is no demand, or it is not suitable. So basically we could use the shelf life feature and detect that what is the shelf life of those produce, and then manage our inventory and storage in that way. Again, we have daily life. So if we convert it into an app, we just scan the fruits or vegetables, whatever it is there, and basically we could get the shelf life, and we can plan our cooking and all based on that. Now, the future scope, as I spoke earlier, is to increase accuracy, of course. So adding more images, changing the approach, maybe optimizers and everything. Then currently it is detecting only one product. We could basically have multiple product detection, converting it into app, mobile app, web app. And then again, as I said, we could integrate robotics, and it could be used in retail stores and companies. So yeah, that's all from my side. Thank you for bearing with me. If there are any questions, I'm happy to answer.
Thank you. Thank you for your presentation. Any questions, ma'am? If the participants have any questions, they can directly, ask the presenter through the chat forum. Any suggestions or any questions? Yeah, thank you. So we have our next presenter with us. Chaitanya, are you here?
Hello.
Yeah, are you ready?
Yes, we are ready. I'll just share my screen.
Yes, please. Start sharing your screen.
Okay. Just let me know when my screen is visible, right?
Yeah. Yeah, it's visible now.
Okay.
You can start.
Just a minute. I'll just put it on slideshow. Is the screen visible?
Yeah.
Yeah, so I'll start. So good afternoon, everyone. My name is Chaitanya Nirfarake, and our paper title is Conversion of Natural Language to SQL Query. And our paper ID is 220. So coming to the agenda for today. So we in the presentation, we have the abstract, motivation, the introduction, the contributions from our side, the methodology that we used to implement this system, the results and analysis, and conclusion and future work. Along with that, we also have the references that we used to research on this paper. So coming to the extract or the outline of our paper. So this paper outlines a method for automating the transformation of natural language queries into SQL queries. And it basically bridges the gap between non-experts and databases. So this is a system where you just give a natural language input, and it converts that natural language input into an SQL query. And this is a rule-based system which converts the natural language to SQL query, and it achieves a decent efficiency, and it also uses well-defined linguistic rules. And notably, the system demonstrates the ability to seamlessly handle basic queries to complex commands. So motivation for this topic was, so currently, as we know, data access is of utmost importance, be it for businesses, for organizations, it is of utmost importance. And having the ability to access data and interpret it, it can help organizations and businesses make informed decision, and they can also help in real-time monitoring. Along with that, it also helps in resource optimization and performance evaluation. So we understand that data access is very important. And most of the organizations or businesses, they use relational database, which is MySQL, SQLite. And these relational databases, they have a slightly complex language, which can only be understood by technical experts. So if you are someone who doesn't have good knowledge about databases or computer science in general, then it will be very difficult for you to access data and from these databases. So having a system that can actually understand your natural language, the language which you speak normally, and convert it into SQL commands, which are very complex, it can be very easy, like for individuals to, with no technical expertise, to actually access the data this way using our system. So this was our motivation. And coming to the introduction, so while thinking about how we could implement this, we actually came across natural language processing, which is a field of computer science that deals with the interaction between computers and humans. So what natural language processing basically is, it tries to understand what the human is trying to say, and it converts that into something which the machine will understand and give an appropriate response. So a small example of this would be Google Translator. As you know, it can understand what the person is saying in that one particular language, and it gives the appropriate response for that query. So similarly, NLP techniques can be used in our system, where the uh, user can just give a natural language query as an input, and we can convert that into SQL commands and directly fetch the results from the database and make it very easy for the user to access the data from the database. So coming to the contribution from our side, so the system that we have built, it is dynamic and it can work with any relational database. So it is not just restricted to MySQL or Oracle. It can be like used for with any relational database, be it MySQL, Oracle, SQLite. So what we currently have is, we have something called as drivers. So these drivers can be made for any relational database, and it could be selected by the user uh, at the start of the process, and he can use the system with any database. So this is something which is unique to our system. And like we researched a lot, and we actually found some similar systems, but none of them were really like generic they were more specific to maybe, let's say, Oracle or maybe MySQL. But our system, it is kind of generic and it is dynamic, so it can be used with any database. The next contribution is we have a state-of-the-art 3 times parsing. So what we do is we parse the natural language query thrice to achieve maximum accuracy. So each of these parses, they actually have a different function, which I'll explain later in the PPT. And the next contribution is support queries. So also, like I said, we saw many similar systems, but very less of the less systems had the capability of join queries. And it has been a limitation to for like quite some time now. And the next contribution is the dynamic table selection. So in these similar systems, what used to happen was the tables which were selected, they used to select all the tables, which even the tables which are not required. So what used to happen is when you select tables which are not required, it kind of takes a toll on your performance. So if the database is very huge and the number of tables are very high, then what happens is if you select all the tables, it takes a toll on your performance and the performance decreases. So what we have is we have a dynamic table selection, which only selects tables which are required for that particular query. So if our query requires just 2 tables, it will just select 2 tables and not the entire tables which are available. So coming to the system block diagram. So our the basic overview of our system is something like this. The core engine is what we call the NLSQL, and the user gives natural language query as an input to the NLSQL. And before that, the user also has to give the credentials of the database. So there is no need for actually inputting the structure of the schema. The user just has to input the credentials of the database, and NLSQL directly fetches the schema and the
Dear
information
presenter,
required.
you have 2 minutes left.
Okay, I'll just try to cover up everything. Sorry.
Okay.
Yeah. So NLSQL directly fetches everything from the database, and then it performs some methodology. We have some methodology which it performs, and it like makes the final query, and it executes that final query on the database and fetches the results and displays it to the front end. So the NLSQL algorithm, which we have is first it fetches the database data, which is the schema. Then it tries to set up the NLSQL engine. So that is something which is like what it tries to do is it maps the columns with the table names, and which we use later in the 8th step, in the 7th step while generating the query. In the next step, it tries to clean the user input by removing stop words and makes the user input more clear. Then it tokenizes tokenizes that user input. And then in the 5th step, we have a three-step parser. In the first parse, it tries to identify the keywords. In the next parse, it tries to identify the table names. And in the third parse, it tries to identify the column names. In the 6th step, what we do is we have to reorder the query. As many a times what happens is the user, he doesn't really care about the order of the query, but SQL is a language which has a particular syntax, and it requires tokens in a particular order. So to ensure that, we have to reorder the tokens which are given by the user. In the next step, we generate the query, and we do this by, we have a particular dictionary, and we map the tokens with the values and create a query. And this query is then executed onto the database, and the results are fetched and shown to the user directly. So for results and analysis, we actually created a data set of about 100 entries, and we have categorized those entries into 4 different categories. The first category being select easy, which puts to test the select and where keywords which are present in SQL. The medium category, along with select and where keywords, also tests the functions such as average, sum, and count. And the third category is hard, where the join functionality is put to test. So it tests the functionality of join of 2 or more tables. And in the extra hard query, in the extra hard category, we have functions average, functions like average, sum, and count, along with the join functionality. And this is what we test in extra hard. So after running the queries and comparing the results, we found out that the easy category had about 100% accuracy, and like medium had 71, hard at 89, and extra hard at about 80%. So overall accuracy of our system was found to be about 85.46%. So to conclude, I would say that the proposed methodology, which we implemented as a tool called NLSQL, it delivers a complete solution for producing SQL queries from natural language. And the system also uses a dynamic table selection, where the program only selects those tables which it finds appropriate to include in the query, as I discussed earlier. And also the user just has to input the database credentials and not the entire schema, which was a limitation in the similar systems. Future work, I would say, is creation of multiple drivers for different databases such as Postgres, SQLite, and SQL Server. And also we could improve the UI of the system. And currently, the system is not yet optimized for data types such as date. So that is also something which we look forward to implementing in the future. And these are the references. Thank you.
Thank you. Thank you for your presentation, Chaitanya.
Thank you. Sorry for exceeding the time limit,
No
actually.
problem. Thank you.
Yeah.
Any questions, ma'am? Okay. So we'll move further. We have our next presenter, Kumar Keshamoni. Are you here?
Yes, ma'am.
Please start with your presentation. Share your screen, please. Please take care of the time frame, and instead of reading the presentation, try to explain and show the important slides.
Sure. Is it visible now?
Yeah, it's visible. You can start.
Like my title is myself, Kumar Keshamoni, a scholar from KLE. Like title is COVID-19 based disease detection on X-ray images using CNN. And coming to like contents, abstract, introduction, purpose and approach, literature survey, implementation, CNN model architecture, results and conclusion as given here. And coming to this, like my abstract, artificial intelligence convolution neural network technique has used finally with the best results has proved in this my technique. And in this my execution, like I was used KNN, SVM, logic regression, decision tree, Navi base, CNN, as well as LSTM, Inception V3, ResNet and mobile net3. So these are the deep learning and machine learning algorithms are used in like my implementation. And among with all the comparison, CNN has proved with the different parameters like accuracy, recall, precision, F-score and false detection ratio. For this analysis, which has moved like with the CNN, and coming to this outperforming with the comparison, just now I told you that these are the different parameters I was used. In this which has mentioned like CNN has given 90.27% of accuracy, and precision is reaching 91.06%, and recall is around 82.4%, and F-score is given 85.61%. The overall metrics what we have. So like this is a like general COVID theory explanation, madam. I said so. I'm skipping because of this is just COVID information. And coming to my CNN. So in this CNN already, which has proved very well in the previous like healthcare industry, like cancer detection, lungs disease problem detection, which has used widely in the worldwide and which is giving very good results. And coming to this my particular like analysis method, which is a non-invasive method and which can be used very easily, because we can say the X-ray facilities is available with various healthcare centers, like more convenient for widespread testing. Like we can get more amount of like X-rays for the comparison and analysis. So this my project is completely like automated tested method. So which was completely developed in the web-based and app-based, we can say, by using Django. The app is developed. After that, in my app, So we have to be upload complete what are the first initially we have a testing purpose like so preliminary questions as given. In the preliminary questions itself they can understand whether the COVID is COVID identified or not. So after that the images uploading process is there. In that process what this we have to do, we have to upload our images in that. So based on that, automatically our system, our app will says whether COVID detected or not, automatically which will be given. So main purpose of this will be like to develop reliable and accurate system for early diagnosis. Because no one nowadays, you know that already COVID when we started, it's already in normal situation. If some symptoms is happened, so automatically we can understand it home places itself. So for these approaches, we have done data set balancing we did, and medical professional analysis with the comparison with the different medical and existing model. And after that, we did data augmentation and architecture for CNN model, which is coming slides, and binary cross entropy loss function and Adam optimizer is used in this one. For this, first we'll say we'll upload the images. After that, data augmentation, model training, then the training model will be tested and prediction of the images will be given in automatically. And this is a literature survey. In this literature survey itself, we divided into so many parts like medical application I was taken separate, and identification of COVID, and different pre-processing data challenges. I was gone through the complete different papers and existing models. And after that, practical implementation in the healthcare also I was observed. And for the precautions, measures, and COVID analysis using X-ray existing models I was also compared here. And in the implementation model, while coming to this implementation model, so I already told you that we have to upload these images. After that, CNN model will be going to be verified and tested. That after that, we are going to get the values in like precision, recall, F-score, and false prediction and accuracy we're going to get. And there is a good opportunity is like users can analyze multiple X-ray images in one session, obtaining individual results for each image. Every image can get different analysis results in my implementation. And this is a model how we need to upload. The first image will says that here the X-ray of the COVID patient, and next here you can see the COVID-19 different patients X-ray data sets, and which has already trained. And next the radiology more accuracy data sets we can take. And here whatever we are showing COVID-19 images, and the below one is the normal images. So this is models we have trained in this process. So this is the image based system development workflow which I am showing now. And coming to this CNN model architecture, we have a different layers like input layer, convolution layer, maximum pooling layers, batch normalized layers, and dropout layers, and fully connected layers, output layer, loss function. And finally, we have a optimizer. These are the levels what we are going to do in this particular CNN model. By this, so image like segmentation will be going to happen, resizing will be going to happen, and filtering will be going to be done in this one. So this is the values I just now in the starting slide itself said. Accuracy, which is approximately 90.28%, which is achieved, and precision 90.54, and recall around 80.364. F-score is 84.05%, and false prediction is 9.7%. Overall, this CNN model demonstrated excellent performance on the training data with highest accuracy. And these are the training data what we have done, and COVID-19 images and like normal images. You can see here the total data is normal images was placed 165, and COVID-19 is a 551. Total images is around 716. In that 17 images are normal images, and 15 COVID testing images. COVID-19 images are
Kumar, move your slides, please. You are still on the second slide.
no, madam, which is already in training.
Okay, why is it showing?
Is
Okay,
it okay now,
continue.
ma'am?
Yeah, correct. Continue. Continue, please.
Yes, ma'am. Yes, ma'am. Yeah. So the testing data is like normal images 17 and COVID-19 images 56, and total testing images are 73. In this total from the data sets we have trained 148 is the normal images, COVID-19 is a 495, 64 total images are 643.
You also have 2 minutes left, yeah?
Yeah, ma'am. Okay. And here, the different algorithm, what I was mentioned, KNN, SVM, logistic regression, and decision tree, and Navi base, CNN, LSTM, Inception V3, ResNet, and Mobile Net 3. So these are the parameters what I was observed here: accuracy, precision, recall, and F score. So among this, I was identified this CNN algorithm. So this results images are showing like person one is the left side, and when I uploaded images, I was like posted directly due to the slides account. So the last image which was showing the COVID detected image. So the result image is showing that. So this is a background which is like an app developed with the help of the Django. For the COVID detected one example sample image. And here I was tested with another person two. Here you can see that no COVID is detected. Like that we can test number of images with this help of this. And evaluation parameters I already told you which is covered. And concluding to like my presentation. So here the efficient COVID-19 detection, this is study presents an efficient and accurate approach for the COVID-19 detection using CNN model X-ray images. For the X-ray images, the proposed CNN model demonstrates the prompting and performance COVID-19 as well as the normal images with respect to the pneumonia also. And here the complete this particular data sets are pre-processing and include balancing medical images, and comparative analysis I was already did. And these are the like from my end, ma'am. Is there any questions? And thank you for giving the opportunity, ma'am.
Thank you for your presentation, Kumar Keshamoni. It was a very good presentation. Thank you. We'll move further. We have our next presenter, Radhika Mundra. Are you here?
Yeah, I'm here.
Okay. Start sharing your screen, please.
Is it visible?
Yes.
Okay. So first of all, good evening to one and all. I'm Radhika Mundra. Thanks for giving me opportunity to present my work here. So my work is on ICT4. It is basically a forensics investigation framework based on Ethereum blockchain. So moving further. So these will be the topic we will be covering. So basically, it's just the introduction of blockchain. Blockchain is basically a distributed ledger technology that consists of a chain of blocks which are linked together with having a hash value, and each hash value depends on its previous block. So we can say that blockchain is a continuous developing, continuous progressing database, which we cannot change, which is once we store a data into that, we cannot change it again. We cannot delete it. It is there for permanent. So it can be simultaneously used and shared within a large number of public people, which because it is decentralized. So data is stored all among the people. So it can be described as a decentralized ledger of all the transaction across a peer-to-peer network, and the transaction data in blockchain is sequentially added. As I said, the hash of a block depends on the hash of a previous block. So blockchain, the main features of the blockchain is it is transparent, distributed, immutable, means it cannot be changed, and it keeps the track of records by maintaining chain of custody. So blockchain keeps a specific role, or we can say important role in forensics, because there are many times we have seen the evidences we have collected or the data we have collected gets modified, gets altered by any person in the chain. So blockchain plays an important role into that. So as I said, it is immutable. So once the data that is stored on it cannot be changed, so we cannot change it, we cannot update it. So whatever it will be, it will always remain authentic. We can always rely on to that. So these are the papers which specifically deals with the Ethereum, and they have, some of them have suggested some framework, some have not, just provided the study, and they have different data storage technologies like blockchain or IPFS, they have used different blockchain type like public, private. So moving further, blockchain technology has been applied in multiple domains other than cryptocurrencies. Blockchain is basically just a most people know blockchain because of cryptocurrencies. It is not just the case. Blockchain technology has been applied into multiple areas, multiple aspects. So it, like information, internet of technology, and so many other storage, cloud storage, and so on. So basically, blockchain is not just about the cryptocurrency. So we have provided this study to provide a forensic investigation framework which is based on blockchain, and we have used Ethereum based forensic investigation framework. So we'll be doing that. So for doing forensics, we need to follow forensics process, which is 5 stages. First is identification. We need to identify the case. Then we have to collect the whatever artifacts we have generated, or we have evidences we have. So when we have collected those, we will examine them. They are with different aspects, with different angles. After examining them, we generate a result, which is analysis. If the analysis is not sufficient, we again go to collection and collect more information related to that, like place of crime, what crime scenes, what we have collected from crime scenes, people, evidences, so on. And again, this is continual process. And after when the analysis has been completed, we go for a presentation, which is report making. So after doing the forensic study, we have to present that data, we have to present our case into the court, so the further proceedings can be done. So this is the whole blockchain, or whole the my study work will be based on this process only. So we have, this is the framework which this is the framework which on which I have developed my framework. I have used Ganache as a testnet environment, which is basically Ethereum environment. And to write a program, or to work on that, we have to write smart contract, which is written in Solidity language. Node 18 has been used as backend JavaScript runtime. Node 18 has been used as a backend JavaScript runtime environment. And I have both used Ganache CLI and GUI and smart contracts, which are written in Solidity language. So this is user level, where multiple users like victim, judge, inspector, advocates, and investigator all are involved into that. Then forensics level, where a new case has been registered, then evidences are collected, which is analyzed thoroughly, and based upon analysis, outcomes are generated. And based on outcomes, we prepare report, and this process is continual process. So, and in the last process,
Dear presenter, you have 2 minutes left.
okay, sure, I'm concluding fast. And the last is blockchain level, where we store the data hashes of our evidences generated. So this is what I explained. And in my framework, I generated these 12 artifacts. So where hash of my block, transactional hash, timestamp, when this evidence, or when this smart contract was compiled, or it came into existence. This is my address. I am the one who created this, and rest are the details. So limitation of my works is that I have provided data in static. So because some limitation to some what I say, some study or limitation to my work, data is provided in static, and it does not address cross-border issues. Basically, blockchain is not just related to one single nation. For dealing with cross-border issues, there should be laws, there should be policies in place. And for time being, I have only stored the hashes of the evidence, not just the complete evidence on the blockchain, as it takes larger space and which involves higher cost to store data on blockchain. So, and most importantly, it requires heavy resources like CPU with 4 cores, 16 plus GB RAM, SSDs, and bandwidth, so on. And so we need to work in this field more. The capacity of blockchain technology to offer a full picture of transaction events back to their sources holds immense promise for the forensics community. So these are the future work which can be completed, which can be covered over the time. Like I can develop, I'm planning into developing an interactive system which for more accessibility since it is just command line at present. So these are the artifacts which I have collected. So, like what when we compile a contract, these are the artifacts generated. What is the gas used? What is the network ID? What are the gas limits? And what is the account number? What is the balance, etc. And what is most important? What is the total cost to compile the contract? That's it. Thank you. Any questions?
Thank you for your presentation, Radhika. Thank you so much.
Thank you.
We'll move forward now.
Radhika, just tell
Yes, ma'am.
me, you said that you collected the artifacts, the forensic artifacts, right?
Yeah,
So from where did you collect this? Because this data is not easily available, right?
ma'am. Actually, I have used testnet. So it is not it is not a real world test place to host a blockchain. So ma'am, as you can see, this is my tool where I executed my
No, what I want to know is, did you actually work on the actual data, or it's just a build-up data? Because it is seeming to be a build-up data instead of being an actual data.
yeah, ma'am. Presently, it is a build-up data.
Right. That's what I get. Okay, fine. Thank you, Radhika.
Thank you, ma'am.
Thank you. We'll move forward. We have our next presenter with us. Abdul Mohammad Abdul is here.
Yeah, can you hear me?
Yeah, I can hear you.
Okay, can I share my presentation?
Yes, please share your screen.
Yeah.
Yeah, I can see your screen. It's visible. You can start.
Okay, thank you very much. First of all, good afternoon to all. And here I am Dr. Mohammad Abdul Rahim, and our paper title is Generalized Technique for Potato Leaves Disease Classification using Convolutional Neural Network. And my speech outlines, I can discuss the introduction part, proposed methodology, dataset, segmentation, and augmentation techniques, convolutional neural networks, experimental performances, and conclusion, and our future plan. In the introduction part, we know that the farmers grow many types of crops, which are the plants that can be grown and harvested on the large scale. In the global scale, there are many types of crops like rice, wheat, sugarcane, corn, soybeans, and different types of, and also the potatoes. We know that in the potato is the most important food crops in the world, and it was the third largest food crops after corns and rice. There is a growing demand for potatoes that are produced professionally, successfully, and sustainability. We know that there are 40,000 editable varieties of potatoes, and it is due to the changing the climate situation conditions worldwide and the changing the consumer demands, it is more crucial than ever to increase the production capability in order to satisfy the future demand. But there is a one major concern that there is many insect and diseases may causes to decrease the production level, and in that case we can think we try to our impact to identify the diseases like the potato leaf disease to grow the production rate. There are two types of we know that there are two types of the diseases, powdery leaf disease, like early blight and leaf blights. In early blights, the symptoms of early blights and older leaves are small, circular, of irregular dark brown in the black species patches. In the right side of the figure, you can see, and also the late blights that presents the black and brown spots on the stems and leaves. You can see, but our targets to prevent the control the diseases to boost up the potato productions. We propose a generalized technique to accurately identify the leaf diseases that helps to take the actions to prevent and control the disease. Here is my proposed methodology. There is we can use the three benchmark data set: potato leaf disease, new plant disease, and plantify the deer. This is the benchmark data set. So we can also consider the potato leaf disease data set, and we can divide our parts: the training data set and testing data set, and it contains the segmentation, augmentation, and training, and the model evolution parts in our works. In the segmentation, the first of all, the data set, there is the number of images in the PD data sets, and 9,510 data images only. New plant data is also, you can see in the table. But after that, we can use the segmentation method. We use the graph cut method that helps to identify only the infected parts of these images and the leaf images, and also use the Gaussian mixer model to estimate the distribution of target and background colors. Also construct a markup random fields across the pixel levels. You can see the early blights, leaves, the segmentation part of this figure. Also, you can see that the number of images is very limited number of images, but that's why in the CNN model we can use the augmentation technique to increase the diversity of the data set and for adapting the real world scenarios and enlarge our data set images. We can use the flipping, rotation, zooming, scaling, height, less, shift, and white shift methods for the augmentation technique. Here you can see the proposed network models, the generalized network models. So we can use the convolutional maximal link layers, and finally we can use the global average polling layers. We know that the CN is a type of deep learning model that is used primarily for image recognition and processing due to the ability to recognize patterns of images in the various types of images. In this models, we can use the 5 convolution and 5 max polling layers, and finally we can use the global average polling layers. In the convolution layers, so two leads that produce the convolution feature from the original images, and next we fed into the max polling to downsample the convolutional features maps. Also, the max polling divides the feature map into different regions, which must not overlap each other. And finally, the gap means global average. Global average for polling layers calculate the average of these regions and produce a final feature matrix that can help to identify and to training and testing of our modeling. Here we can divide our training and testing data sets. In the training, we can use the 80% of the data set images for the training purposes, and the testing purposes, we can use the 20% data set images. Front and see the average training accuracy of different data set. We can use 3 data set. I said before, 99.9%, 90%, 99.84%, and 99.90% for different 3 more data set. And here we can use the 3 data set in combinedly. We can use the mix. We mix the data set images in one. We make one data set, and we can also apply our method to identify the images. We can achieve the good result also. using the combined data set also. We can, let's say, we can say that this is the generalized a model that can identify the images easily for using the different data set. And finally, the average training accuracy is 9.89% accuracy, and the testing is 99.98% accuracy. It's
Dear
also
presenter, you have 2 minutes left.
okay. Here is our the model loss and accuracy for different data sets, and also we can also use the comparison results with the different models. How the effect our the models. We can use the random forest, BCG16, YOLO, V5 methods, but we can see that our proposed method is still better than the reported methods. And finally, I can say that we can propose, but you can employ a generalized deep learning models that helps to identify in using the different data set images. We can apply our model, and also we can use the benchmark data set and use the segmentation technique, graph cut we can use, and also the use this augmentation technique, different augmentation technique, and also we have achieved the good results. And finally, in our future plan, we use our also the own. We have planned to create the own data set also, and to compare it in the real-time applications using the easily available devices like Android phones and also the another versions. Thank you for your kind attention. Have you any questions?
Thank you for your presentation. Any questions, ma'am?
Yeah, I just want to know, your accuracy is very high. In certain cases, it's even 100%. Did you try changing the values once? Because this much accuracy shows that your data is perfect.
Yeah, data, madam, you can see the data set image is not too large, but we can try to the augmentation technique. That's why we need the big data set. We can prove our accuracy model is good or
What
not.
was the total number of
But in this
values
case,
which were there?
Sorry.
I'm just asking, what were the total
There-
number of values which were there in the data set?
In data set and this model, the original image is 20,000, and after augmentation, we can get it to the 98,000 images.
Okay.
Thank you, madam.
Okay, we'll move forward. Thank you. We have our next presenter, Rahul Daugure. Are you here?
Yes, Deepika.
Thank you. So you can start sharing your screen.
Yeah, I hope the screen is visible.
Yeah, it's visible. You can start.
Yeah, thank you, Deepika. A very good evening to the session chair, the presenters, myself, Rahul Dhaigure, and my co-author, Dr. Ruby Chanda. We are from Symbiosis Institute of Management Studies, Pune. The earlier presentations are completely different. Ours would be, a little bit different. We are from the Management Institute, and that's why, using those computer systems to, solve our problems is what we are thinking of, and that's why that's how we have come up with this paper. So the title of the paper is Intelligent Decision Analysis to Stimulate Student Learning. As you know, the Indian learning forms of the students are quite different from the Western cultures. What we can say is the Western cultures, they are quite different in terms of using the technology and the interaction with the students. We are very much exam centric. They are very much, application centric. And in India, what is happening with the management education is in most of the institutions, we are still concerned about the exam scores. Whereas when the students are going to become managers, it is more important that they are able to use their knowledge in the real life scenarios, which we, see is happening at a very lesser this thing. We still are trying to make a point that the students should be able to, apply their knowledge in most practical based manner. And we are trying to also use this multimedia technology so that the learning experience of the student gets better, and they get more involved into teaching learning process. Forget about the literature review. I've just quoted 3-4 things. uh, the objectives for this paper is to assess the effectiveness of strategy for the management college teachers to stimulate the students learning motivation. Now, what we see is most of the times when you enter into the class and the students are sitting in the class for the whole day, you see the students losing their motivation and their interest in learning or in the sessions. And what happens is, in a class of say minimum of the 60 students, which we have like a batch of 60 students in a division, we cannot assess all the students at one go, and that's a big problem for the Indian institutions when there are large number of students sitting in a class to assess their learning abilities. On that basis, if you look at the NAC guidelines, also NAC also asks us or expect us to assess the learning styles of the students, of each and every student, also use the student centric methods. And since we know that the students have different learning styles in a class of say 60 or 60 plus batch, and their learning levels are also different, teaching those students become a bit difficult for the faculty, or what we can say nowadays is a facilitator. And the students lose the interest in learning, because for a particular group of students they find it very interesting, but for the other remaining students they don't find it very much interesting. So based on that, previously the NAC used to call the students as slow learners or advanced learners, and they asked the institution to give what are the strategies they are developing for addressing the needs of the slow as well as advanced learner students. So in this case, we try to find out what are the different levels of the students. We try to assess the students when they enter in the college, at what level they are, and if a particular group of students is lagging behind, how we can motivate them to participate in the class discussions, and they also come along with the other group of students, what we call as maybe advanced learner students. So in this case, we try to set up a quantitative hierarchical structure model, because at a point previously when we used to group the students into slow learner and advanced learner groups, it was pretty subjective decision based on the observations of the faculty in a span of say initial 1 month, and that was very subjective, could be biased, and we wanted to come out of that. So we thought of using a quantitative model which would be more robust and which would be more objective based. So this quantitative hierarchical structure model help us assess the student and then decide the strategy for our teachers to teach them. So when we implemented this particular model, uh, how we did it is, uh, there were around 314 students which were admitted to the first year program. So we take the tests for them based on the aptitude, general knowledge. Along with that, during the orientation period of time, the student council and the faculty in charges, they observe the students. And there are some scores given to each and every student. Based on the collective scores, we divide them into two groups. It is not actually good to call them slow learners and advanced learners, but these are the terminologies given by NAC. So we use these terminologies, but they divide the students, looking at their presentation skills, their communication skills, their aptitude, and some other factors as well. Out of the 314 students, we tested this particular model on 34 students, which were, observed by the student council, the faculty in charge during the orientation period, and the test that we conduct before they, come to the college. Uh, we divided this into group A, group B. Then based on this hierarchical model, we got some comparison. We figure out some variables which stimulate or which affect the learning ability of the student through the literature. So you can see five important factors which affect the students' learning is the teachers and teaching method. So when the score is higher, it means that they are the broader categories, and when the score is lower, that means they are the specific. So teachers and teaching methods are the broader categories which affect the students' learning abilities. After that, if you look at it, is multimedia information courseware, teaching case-based studies, and simulation. So these three factors are mainly, affecting the students' motivation to stay in the classroom. So based on these three main thing, keep aside the teachers and teaching method, because teachers would always be there in the classroom. They will be using different teaching methods. But while using these teaching methods, what then we try to incorporate is they use mostly the multimedia courseware, uh, uh, teach them cases, more and more cases, and use the simulation softwares. So while teaching this group of 34 students, the faculties, they were told to use more and more ICT based tools in the classroom for a special group of students, so that we can motivate them more and more. After conducting these classes for say 3 months approximately, before the conclusion of their first semester, we took the test again, and this is the result where you can see that uh, after the test was conducted, the score of group A is 7.75, of B is
Yeah,
6.85. These are the
presenter,
slow
you have two
learners.
minutes left.
Yeah, yes, Deepika, I'll be concluding.
Okay.
Thanks. So this is more than group B, which is advanced learner, and this is slow learner. So with this particular experiment, what we come to know is that if you use these ICT tools effectively, then we can motivate the students to learn and improve their, probably the community. These are the points we had, fixed, like communication skill, presentation skills, and a little bit of aptitude. So if you look at the findings, then we get the analysis in a vector format, shows the different factors to target, uh, the slow learners compared to the schema class, which is advanced learners or the normal students. We try to find out the relationship between the factors. So which were the 5 factors which came through the literature. Then we rank them according to their scores. More score means broader factors. Lower score means the specific factors which we should be focusing more and more. So these are the factors: teachers, teaching method, multimedia information courseware, teaching case-based studies, simulation. And when these 3 factors, like multimedia courseware, case-based teaching, and simulation, this all can be used with the use of ICT mainly, where the students find it interesting instead of just delivering the sessions. So finally, by using this quantitative method, hierarchical structure method, instead of having the subjective and biased views of the faculty towards a particular group of students, saying that they are not motivated, or they are not coping up with the other students, we try to figure out that their learning needs are different, and what are those strategies that the faculties should adopt to motivate these students. We use this hierarchical structure method, come out with the factors. We figure out which factors we should be focusing on, and based on that we ask the faculty to change their teaching methods, and finally we try to motivate the students and you know learn better and participate probably in the class discussion, and make a teaching learning activity fruitful. Yeah, that's all. These are the references. Thank you. If any questions, I'm open to it.
Thank you. Any question? Okay. Move further, we have our next presenter, Swanand Mulay. Are you here?
Hello.
Yeah.
Yeah, I'm here. I will just share my screen.
Yes, please. Share your screen.
Good evening, everyone. So our paper title is a survey on IoT-based smart irrigation system, and so our ID was 212, and these are my teammates who are also present in the meeting. So to give a general introduction, agriculture is like core for economy of any country, not just India, but in the whole world. And as in this technological era where we are making new advancement in technologies every day, like incorporating those changes in the agriculture will be very beneficial. And the best way to do is with the help of Internet of Things. With the help of IoT, like Internet of Things, we can monitor soil moisture, temperature, and nutrition level, pH levels, and whatnot. And by collecting that data, we can visualize it and also use that data to take uh, data-driven methods to improve our crop or boost efficiency of our agriculture systems, which will be very beneficial. So, keeping that in mind, we decided on problem statement of making secure, user-friendly, smart irrigation systems, which are also cost efficient. So to make some progress, we broadly decided our objectives to be first adding security aspect to IoT irrigation, and second to be like solving the current issues faced in the existing IoT systems, and plus making it user friendly and accessible for every small scale as well as big large scale farmers. So the like to think about the motivation behind this, first we can say we are farmers, and therefore, and from like while being from the area which lacks which has scarcity of water, we felt the need of smart irrigation systems. Like we thought it will be very useful, and along with that we thought of publishing this paper to contribute to scientific community, so that this issue will be in the spotlight, or it will be highlighted and more work will be done on it, which will also benefit the society. So to do anything, we first did a survey on what are the things present and what are the things need to be done. So we quoted a few papers here. So basically, I will just summarize them for you. What they do is like they will monitor different parameters like soil moisture, pH level, or humidity, temperature, and based on that, they will either program microcontroller to turn the water pump on or off, or otherwise they will have an app or some framework to show the data and let users control the microcontroller. Most of them just tried with various sensors or tried with different microcontrollers or different circuit designs. So while doing this survey, we observed some key factors, like all of them were lacking in security. None of them made any active efforts to securing the data, because like when we talked with other people, we found out that people have the mentality of saying like it's just agriculture data like temperature and all, so it's not that important to be encrypted. But that's not the reality. Actually that data also should be that data also is very crucial, and not just the data. A third party attacker can also control your the actual device or microcontroller and use it for different purposes. So therefore security is very crucial in smart irrigation systems as well, and we should also focus on that. Other than that, it was hard to use. Whatever, like most of them didn't have any UI UX, and the some of them which had, they didn't make any active efforts in designing it better UI or having a good user experience. So the issue with this is like it will make harder for farmers to adapt to it. Because if there is some simple UI which looks good, farmers will be like more than ready to adapt to it. And the one more thing is it's the systems being expensive due to use of like uh, more more powerful microcontrollers, which can be avoided. So we decided to tackle this issue in the order of like that. We first decided our system must be secure, and then we decided it should be like it should have good UI UX and then expensive. So we also like based on the survey, we also proposed the system which have like authentication and encryption authorization in place, so that our system is secure, and we also try to avoid the memory corruption issues. So the basic requirements for our system was, for hardware part it was the same, the microcontrollers and sensors as per need, but for the security on the software part, we decided to use Rust programming language to program the firmware of our microcontroller. because as per the Microsoft survey, like 70% of the vulnerabilities are due to memory corruptions, which are majorly due to use of unsafe languages like C or C++. So we decided to use Rust language because it's memory safe, while it provides same performance as CPP. So other than that, we also have a cloud backend, which I mentioned, which will be used for visualizing the data or doing the further process on the data, and for uh, like transferring data from cloud backend from the client and sending commands from cloud to clients. We will need a MQTT broker. I will like get back on it more. And other than that, there are just some dev tools and simulators for developing prototypes and testing, for example, like OQ simulator and all. So what are the protocols and algorithms we will be using for securing system? First, for the transferring of messages and communication, we will be using MQTT, which stands for Message Queuing Telemetry Transport. Like the reason behind using MQTT or HTTP or anything is because it's energy efficient, and like it it efficiently manages the network bandwidth. So it's very commonly used in the IoT applications, and it's based on the publish subscribe model. So there is one broker, and the client can be publisher or subscriber, where the publisher publishes to a topic, and subscriber can subscribe to one or multiple topics, and that way they communicate with each other. But like having just a communication protocol is not enough. We also have to
Dear
secure it.
presenter, you have 2 minutes left.
Yeah. So we added SSL algorithm for securing the MQTT. So in fact, we will be using MQTTS, which is similar to HTTPS. And other than that, for authorization part, we will be using RSA algorithm for like key exchange and certificates. So to broadly, our architecture will look like this. So whenever user is trying to access or send commands from the web, he first have to authorize himself that he is the actual user. And whenever our microcontroller is like transferring the data to the web API or receiving commands, they will also have to authorize, and all the data while from the sensors or from MCU to our web API to our cloud will be encrypted using SSL or TLS protocols. So that like that's how we are going to add security. And to conclude my presentation, we hope like we are going in the correct path to secure the smart irrigation systems and making it more user friendly, so large scale or small scale farmers can adapt to it. So thank you for listening to me. If you have any questions, please feel free to ask.
Thank you for your presentation. Any questions, ma'am? Okay. Thank you for your presentation. One minute. Okay, so we have come to the end of the session. I sincerely thank all our authors and presenters for their excellent presentation and contribution in this session. I hope this session was informative enough. We, on behalf of the entire team, thank you for your support during the eighth version of the conference, and we hope to see you in the next version as well. All the presenters would be getting their certificates through email within 2 working days. And further, all the papers have already been forwarded to the Stringer board, and the publication will be live in 6 months. So please cooperate with the team. I also thank our session chair, that is just a minute, Priyanka Verma, for chairing the session. This is a token from our side, ma'am. Thank you for the chairing the session, ma'am. Thank you so much. Okay, I request all the participants to just switch on the cameras so that I can take a quick snapshot. One minute.
I'm not able
Please
to-
turn on your cameras,
I'm not able to
ma'am.
turn my camera.
Yeah, I'll do that.
Okay. Thank you. Thank you, everyone. It's done. Thank you.